As requested, here's your question number 43 from topic 6 for AP Physics C. You have a set of data collected experimentally. During that experiment, mass was altered and the mass was propelled by a piston that exerts a constant force, and that you can think of a barrel of a gun 15 centimeters long. So that's displacement. So displacement is constant and it equals 0.15. We can figure out V final is a variable, V initial is 0. So maybe something like V final squared equals V initial squared plus 2. Acceleration displacement comes to mind, hopefully, where we can grab this out because it's 0. So then V squared equals 2 acceleration change in x. We know this. That is a variable. I could calculate it, or I could just replace acceleration through this. So what I'm going to think, I need to get a straight line relative to something. So it should look like this. And I could find a slope. And that slope should help me figure out this force. So let's look at the data again. So force is constant. So as mass grows, acceleration is dropping. So if I did something like mass versus acceleration, I wouldn't get a straight line. But what you should think of is acceleration equals force over mass. So it's like something times 1 over mass. So if I graph acceleration versus 1 over mass, that will be a straight line. Problem is I don't know acceleration. I could potentially calculate it, but why bother? Why don't we graph V squared? That would be meters per second squared versus 1 over mass, which is 1 over a kilogram. In that case, we will have a straight line. Well, it probably won't go from 0 because it's an experiment, but something like that. And then if we find this slope, V squared over 1 over mass, that will be like V squared times mass. Well, and again, force, mass times acceleration, so I got mass here, and acceleration from this formula is V squared over 2 change in x times mass. So if I figure out the slope of this graph, so the slope of the graph that I show you on the right, V squared to 1 over mass, or V squared times m, force is what I'm after. I need to just take slope and divide by 2 change in x. Here's my graph. I plotted 1 over mass along my x and V squared along the y. 1, 2, 3, 4. Here's my fifth. 1, 2, 3, 4, 5 dots that I got. Started at 1, ended at 5 because it's 1 over mass. 1 over 1 is 1. 1 over 0.2 is 5, and then velocity is growing as mass is dropping. So if I do 1 over mass, I can get a straight line. In the equation for this line, I see that the slope is 17.74. So slope of the graph, so again, reminding you, we got 1 over m and V squared over here, V squared over m, and that would be like kilograms meters per second all squared. So if you think about it, it's like newtons. Force is in newtons. Newton is in kilograms times meters per second squared. So if I divide this slope by meters, which is x, I'll get to my newtons. 17.8 is force times 2 displacements. 2 displacements is 0.3 because the displacement is said to be 15 centimeters. So when I multiply it by 2 and convert it to meters, I get 0.3. Then force equals 17.8 divided by 0.3, about 59 newtons.